50,000 years ago, in a cave somewhere in what's now northern Iraq, a group of people is burying one of their own. They dig into the earth by hand. They lay the body down carefully, arms folded, head turned just so. Someone places flowers on the grave. Actual flowers, pollen from yarrow, cornflower, and hollyhock, pressed into the soil around the bones. Someone else has been caring for this person for years. His arm was crushed and useless. He was blind in one eye. He'd lost most of his teeth. And still, this group kept him alive, fed him, protected him, long after he stopped being useful to anyone. That person wasn't one of us. He was a Neanderthal. And here's the question that should be bothering you right now. If Neanderthals were capable of grief, of ritual, of caring for the disabled, and if, on top of that, their brains were physically bigger than ours, why are you here and why aren't they? Let's actually define smarter, because that word is doing a lot of lying in casual conversation. Brain size isn't intelligence. If it were, sperm whales would be running the planet and we'd all be taking orders from an elephant. What actually seems to matter is a combination of things. How much of the brain is devoted to processing information versus just running the body, how the neurons are organized, how much working memory you've got, and critically, how well individual brains can network with other brains. That last part is going to matter a lot later, so file it away. Neanderthal brains averaged around 1,500 cubic centimeters. Modern human brains average around 1,350. That's not a small gap. That's roughly the difference between a large grapefruit and a small one sitting inside your skull. And a big chunk of that extra Neanderthal volume went into the occipital lobe, the part of the brain that processes vision, and into areas linked to sensory and spatial processing. Some researchers think this means Neanderthals had sharper eyesight and better spatial awareness than we do, adaptations for hunting in the low light of Ice Age Europe. So on paper, you've got a species with more raw processing power, built for a brutal environment. Who got there first? Homo sapiens didn't even show up in Europe until Neanderthals had already been living there for over 300,000 years. Now look at what they actually did with that brain. Neanderthals made composite tools, stone points glued onto wooden shafts using pitch they extracted from birch bark through a multi-step heating process that modern chemists have struggled to replicate with primitive equipment. That's not trial and error. That's planning, chemistry, and patience. They controlled fire reliably. They wore clothing sewn from hides. At a site called Bruniquel Cave in France, Neanderthals built strange ring structures out of broken stalagmites, deep underground, in total darkness, for reasons nobody has figured out. That means they were carrying fire hundreds of meters into a cave system for a purpose that had nothing to do with survival. That's not instinct. That's culture. There's also the matter of what they left on cave walls. At sites in Spain, red pigment hand stencils and geometric patterns have been dated to over 60,000 years ago, tens of thousands of years before Homo sapiens ever set foot on that peninsula. Whoever made those marks wasn't a modern human. There was no one else it could have been, which means the oldest known cave art on the European continent isn't ours. It's theirs. And it's not just Neanderthals making us look average. Homo naledi, a small-brained relative discovered in a South African cave system, appears to have deliberately placed its dead deep inside chambers that are almost impossible to reach. Chambers so tight that modern researchers had to hire slender cavers to squeeze through. A brain a third the size of ours, potentially doing something we associate with religion. Denisovans, known mostly from a handful of bone fragments and DNA, were living on the Tibetan Plateau at altitudes that would give you altitude sickness within hours. And they weren't just surviving there. They were thriving thousands of years before Homo sapiens figured out how. A Denisovan jawbone recovered from a cave at nearly 11,000 feet shows they'd already solved a physiological puzzle we're still studying in modern high-altitude populations. And in a strange twist, the gene that lets Tibetans today breathe easily at that elevation was likely inherited directly from them. Even Homo erectus, a species that shows up over 1 million years before any of this, was making ocean crossings. Not accidental drifting, deliberate voyages on some kind of watercraft to reach islands like Flores in Indonesia, separated from the mainland by open sea. Nobody has found the boats. But you don't end up on an island your species has no evolutionary reason to reach without building something and getting in it on purpose. So here's the twist. If they were built better, equipped better, and in some cases got there first, why are you the one watching this video and not a Neanderthal? Because being individually capable was never the whole test. Survival isn't a solo intelligence exam. It's a group project, and most group projects are won by whoever coordinates better, not whoever's smartest. Genetic evidence suggests Neanderthal populations were small and scattered, maybe never more than a few tens of thousands of individuals total, spread thin across Ice Age Europe in isolated bands. Small populations mean small gene pools, which means less resilience when things go wrong. A bad winter, a disease, a rough decade of failed hunts. Their tools, for all their sophistication, stayed remarkably consistent for tens of thousands of years. A Neanderthal hand axe from 100,000 years ago looks almost identical to one from 50,000 years ago. Compare that to Homo sapiens, whose toolkits kept changing region to region, generation to generation, sometimes within a few thousand years. That consistency is actually the clue. It suggests Neanderthal groups weren't talking to each other much. Homo sapiens groups, on the other hand, left evidence of long-distance trade, shells and pigments moving hundreds of kilometers from where they originated, meaning separate bands were in contact, swapping materials, and probably swapping ideas. One smart Neanderthal who figured out a better spear point might die with that knowledge if his band was isolated. One clever Homo sapiens sharing that same idea could spread it across an entire continent within a few generations, because the social network was wider. Population density backs this up in an almost brutal way. Some estimates put the total Neanderthal population across their entire range, at any given time, somewhere in the low tens of thousands. Homo sapiens, once established, likely outnumbered them many times over, not because sapiens bands were individually bigger, but because there were simply more bands, staying in contact, refusing to stay isolated. Numbers plus networking beats brainpower plus isolation. Every single time evolution has run that experiment. This is the part that should reframe everything you think about intelligence. It's not about how good any one brain is. It's about how many brains you can plug together and how well the ideas move between them. Cognitive scientists have a term for this: cumulative culture. It's the ability to build on the last generation's discoveries instead of relearning everything from scratch. A Neanderthal genius still had to watch his knowledge die with him if nobody was around to hear it. A mediocre Homo sapiens with a big tribe and a trade network had an entire species worth of accumulated tricks to draw from. Think of it like this. One Neanderthal inventing a brilliant new scraping tool is a single flash of light in the dark, gone the moment he dies. One Homo sapiens having a decent idea and mentioning it to his cousin 2 valleys over is a fuse being lit. It doesn't need to be the better idea. It just needs to keep spreading. There's also the interbreeding twist people love to skip over. Neanderthals didn't fully vanish. If you're of non-African descent, somewhere between 1 and 4% of your DNA is Neanderthal. Some of it is still doing work right now, influencing your immune response, your skin, even how you metabolize certain drugs. Some Neanderthal-derived genes are linked to how efficiently your body responds to infection. a possible leftover advantage from tens of thousands of years adapting to European pathogens sapiens hadn't encountered yet. In a strange way, they didn't lose. They just stopped existing as a separate species and got folded into us. Which brings us to the part that should actually bother you. We like to imagine that we're at the top of some evolutionary ladder, the smartest version of human that's ever existed, the finished product. But the fossil record says otherwise. It says intelligence, at least the individual, raw processing power kind, might not even be the trait natural selection was optimizing for. What it seems to have rewarded, over and over, is connection. Bigger networks, wider trade routes, more ears to hear an idea, and more mouths to repeat it. That's an uncomfortable thing to sit with in a world that worships individual genius. The lone inventor, the misunderstood mind ahead of its time, the tortured artist working alone. The Neanderthals might have had more of exactly that kind of individual talent than we do, and it didn't save them. What saved Homo sapiens wasn't necessarily being smarter. It was being more connected. Being, frankly, a little more social and a little more willing to talk to strangers. And if you want the modern version of this experiment, you're already living inside it. The reason a mediocre idea posted online today can outperform a brilliant one whispered in a closed room isn't a mystery. It's the same mechanism that let Homo sapiens outsurvive a species with a bigger brain. Reach beats raw talent. It always has. Every collaborative tool, every shared document, every group chat where someone says, "Wait, try this instead," is a tiny echo of the exact advantage that let your ancestors outlast people who were, by most physical measures, better equipped than they were. So think about that the next time you're impressed by a single brilliant mind working alone in a lab or a garage. That's the Neanderthal model. It's the model of the group, the messy, chattering, idea-trading network of ordinary brains that actually won. Go back to that cave in Iraq, to the man with the crushed arm and the missing eye, buried under a handful of wildflowers by people who had every practical reason to leave him behind and didn't. He was, by almost every physical measure, better equipped than you are. Bigger brain, sharper eyes, tougher body. He's gone. You're not. Not because you're smarter than he was. Because somewhere behind you, there's a chain of people who never stopped talking to each other.